Assalamu alaikum students. Today's our topic is about definite integral. So before defining definite integral, we have to discuss two concepts. The first one concept is area under the curve. We define the area under the graph of a function f from a to b as a limit of the form limit del of x approaches to 0, summation which is vary from k to 1 to n function of omega of k times del of x, where we restricted f and del of x as follow. That the first point is the function f is continuous on the closed interval ab. That we have this diagram. In this we have the function y equals to f of x, which is a continuous function on the closed interval a and b. F of x is non-negative for every x in the interval. Then all the subinterval x of k minus 1 into x of k have the same length del of x. Then the next step is we divided this interval a and b into equal subinterval x naught, x1, x2, x of k minus 1, x of k up to x of n. And their length is equal. Their length is equal to del of x, which is equals to b minus a over n. The number omega of k is chosen such that function at this point is always the minimum or maximum value of the function on the interval x of k minus 1 and x of k. Mean at that point we choose any point omega of k or u of k. It is any arbitrary point. At that point we say that our function attain maximum or minimum value of the function. Then we define Riemann sum. The Riemann sum is let f be defined on a closed interval ab and let p be the partition of this interval. A Riemann sum of f or f of x for p is any expression r of p of the form mean the area under the curve which we have defined before. It is equals to your Riemann sum, which Riemann sum is where omega of k is in x of k minus 1, x of k and k equals to 1, 2 up to n. So this total area under the curve is equal to Riemann sum. Then we define or we come to the definition of definite integral. Let f be defined on a closed interval ab. The definite integral of f from a to b denoted by a function integrated from a to b point is equal to a to b f of x with respect to x is equal to limiting value of the Riemann sum. When we have the Riemann sum, we apply limit on this sum. And if this limit is approaching to 0 and it is any definite number, then this definite number is called area under the curve or definite integral of the function. And this limit must exist in this case. We have some certain point here. Letters other than x may be used in the notation for the definite integral. If f is integrable on interval ab, then this integral can be written in the form of f of s ds, f of t with respect to t, mean that this x is only dummy variable. We can use any variable instead of x. So it is your dummy variable. Then next we come to the properties of the definite integral. Now first one property of the definite integral is if c is greater than d, then integral from c to d f of x with respect to x is equal to minus time d to c f of x dx. Mean in this case if we rotate this integral from d to c, then we will also apply negative sign with this integral. If f of a exists, then from point a to a f of x with respect to x is 0. Mean at the point area under the curve is also always equal to 0. The third one point is if f is integrable and f of x is greater than or equal to 0 for every x, mean the function is integrable and it is non-negative. for every value in this interval, then the area of a region under the graph of f from a to b is your definite integral. That is, area under the curve is always from a to b f of x dx. Now we will explain this definition with the help of example. Here we have integral from -2 to 4, 1 by 2x plus 3 with respect to x. Now here we have function 1 by 2x plus 3. Now you can see it is simple linear line. So first we draw the graph of the function, and for this we need some particular values from -2 to 4. Substitute these value, you will be obtain your corresponding function value. Now we will plot these value on the diagram. We will have this straight line from -2 to 4, and the area is under this graph. Now for this we will simply calculate. The value of the integral is numerically equal to the area of the region under this line from x equals to -2 to x equal to 4. Now substituting these values, and we will solve this integral with the help of simple your integration rules. We will obtain the value 21. Now area under the curve is equals to 21. Now we have another example. It is from -4 to 4, 16 minus x square under the root. Now here f of x is equals to 16 minus x square under the root. Now you can see it is simply the equation of circle. X square plus y square is equal to 16. You can see it is the equation of circle with radius 4. Now, so the graph of the function is semicircle from -4 to 4. Now, solving this integral solely with the help of formula which we have for the circle. Formula of the circle is area of circle is equals to, as we know, area of circle is pi r square. Now here we have semicircle, mean half circle. So we will multiply 1 by 2 here. 1 by 2 pi r square. So simply substituting the value of r, which is